So on the schedule, the P5 says day 1, day 2, but it's just one lecture. So we'll do as much as we can today, finish up whatever is left tomorrow. But there are 2 worksheets. There is a day 1 and a day 2 worksheet, so you expect it to do both of those. Solving inequalities algebraically and graphically, so we do some of the inequality work today. It is still rules of algebra. So if I'm going to get my x's by itself in this first problem, the first thing I'd probably do is bring the 2x to the other side. Move the 3 back to the other side. So it's not any different than what we've done in the past. Finally, divide by 4 on both sides. And get x greater than 2. So that's an algebraic solution. It is no longer one value, right? It's all the x's that are less than 2. So if you look at the instructions where it says solve and graph, they're not necessarily saying like graph it on an xy plane. Really, they're talking about go to a number line. The number 2, let's say, is sitting right here. Because it's greater than, it's what you call a strictly greater than. There's no equal to symbol under this. We're going to put an open dot. And then would you shade to the right or to the left of that dot? To the right. So a graphical representation on the number line is saying 2, but not including the 2 and anything out to infinity. So all the x's are greater than 2. Another notation would be to write interval notation. And so sometimes having the number line is nice. So what's the leftmost answer? 2. What's the rightmost answer? Infinity. Now infinity is when you do interval notation, never get square brackets. They get a parentheses. And then the 2, because again it's an open dot or greater than, also would get a parentheses. Okay? And we'll see the difference in just a second. But over here in the box, this is what they talk about like when you're doing your different notations. The open circle, the parentheses, less thans, greater thans, closed dot, square brackets, that's where you would see the less than or equal to or the greater than or equal to. So when you see the closed dot, brackets, or the equal to symbol, it means the endpoints still satisfy the inequality. Bless you. Anything to get on the pre-calc lecture video, that's good. This one, same thing, what would you do first?
Subtract 2.
Okay, let's subtract 2. As long as you follow your rules of algebra, we're going to be fine. At this point, there are a lot of different options, and you guys may handle it differently, so somebody give me something they do next. You can multiply by 4. That's fine. Like I said, a lot of different options. What else? Divide divided by the negative 3. And what did I hear? Nice. 20 divided by 3, 6 2/3, if you want to go to that.
Why does the sign switch?
Because we divided by a negative. So, that's our algebraic solution again. On a number line, you'd put, 6 2/3 or 20/3. However you're going to write it, it doesn't really matter. But this time, it has the equal to symbol, so we're going to use a closed dot. You fill it in. That means that actual point is working. Should I shade to the right or to the left? Left is the stuff that's smaller or less than, so it's going to go all the way to negative infinity. So the interval notation then is negative infinity all the way up to, again, 20/3 or 6 2/3. Now, infinities always get a parentheses. There's no actual value there, so you can't ever be equal to it. But because the dot is closed, we will put the square bracket around the 20/3. So any one of these three forms would be good. And so really the rule that we want you to remember you will always switch to inequality if you divide, and I'm going to put in there, or multiply by a negative number. At this point, right here where we divided by the negative 3, it is possible that some of you may think that as multiplying by negative 1/3. So that's why I say divide or multiply by negative. You can add and subtract all day long, and you never flip your inequality. You can multiply or divide by positive numbers, and you never flip the inequality. Only when you divide or multiply by the negative should you flip your inequality symbol. Now this is kind of what I call like a 3-compartment problem. There are 3 areas in the problem because we have the 2 inequality symbols. And so the 2x minus 1 is being sandwiched in between negative 7 and 9. If you graphed it on an xy plane, you'd have something down here at negative 7, and you'd have another one up here at, positive 9, and then 2x minus 1 would do something like this. So what they're asking you for are this green line is hitting the red, so your linear is above the red line from this x, and then it's below the blue line from this x, and so you want to find the 2 x values for which the green line is between the red and the blue line. That's ultimately what they're asking. So you go plus 1 everywhere. Negative 7 plus 1 is negative 6. And so the idea is you're going to isolate your variable right down the middle. So you get the x all by itself. So our next step is divide by 2 everywhere. And we get negative 3 is less than or equal to x, which is less than 5. So your x is somewhere between negative 3 and 5. Now notice we have 2 different inequalities in it, right? one's a strictly less than, and one's a less than or equal to. So on a number line, you would put your -3 and your 5. Because the 3 is sitting next to a less than or equal to, we will close the dot. The 5 is sitting next to a strictly less than, and we leave an open dot, and then where do I shade? Right down the middle. And then our interval notation goes from -3 to 5. Square bracket around the -3 because -3 will work. And anything up to 5 works, but not exactly 5. So square bracket